Good morning.
Good morning.
There we go. All right. Okay. So now we're doing antiderivatives, which is the opposite of derivatives. Thank you. All right. So it's actually super easy. Super easy. Super easy. You're going to be like, mad, why didn't we start this earlier? Well, you have to know what a derivative is first to figure out the antiderivative. Function capital F, if you notice, is called the antiderivative of function f, where capital F prime of x is equal to f of x times f prime of x, which is f of x. Does that make sense? Okay, yes. Remember the prime. What does the prime mean? The derivative, right? But the capital F is the antiderivative. Okay? It's going to be the antiderivative. Okay, so it's actually super easy. It's just the notation that's probably going to get you for a while. Right here. So if a function capital F is an antiderivative of a function f defined by an interval I, then the other antiderivatives of f has the form f of x plus c, where c is some arbitrary constant. Let me explain why. Starting off with, I'm going to do a quick derivative. Okay, so if I'm starting off with f of x is 3x squared plus 2. If I take the derivative, that would be my f prime of x is going to give me 6x, right? Okay. But the antiderivative is going to do this right here. Watch very carefully what I do right here. When I take the derivative, I take the exponent and multiply by out front, right? Now, when I do antiderivative, okay, we're going to do opposite. So now, instead of taking the exponent multiplying out front, instead of multiply, I have to divide. So I'm going to divide. So I'm going to divide, right? Turn red. So I'm going to divide. Okay? And I always subtract 1 from the exponent, right? So I'm going to add 1. So this is now going to become, if this is 1, this becomes 2. But then, remember, what did I divide it by? I multiplied by the exponent, right? Then I subtracted, right? So 2 times 3. Yeah, then I subtracted 1 from my exponent. So now we're doing it opposite. So I add 1 to the exponent, which is going to give me the 2, and then I divide by it. Yes? So that's going to be the antiderivative of this. But now when I do the antiderivative, I need to get, how would I get the 2? Remember, the 2 just drops off when I take a derivative.
You add c.
That's where I get my plus c. Because you cannot figure out the number because this goes to 0, right? The derivative of 2 is 0, and we can't figure out what it is. So we know that it's going to be some constant, some arbitrary constant. That's where we get that from. So if I did this right here, and then it comes back to f of x gives me 3x squared, right? Plus c. Do not forget the plus c. That is always for my antiderivatives. Antiderivative, also known as integration. Okay? All right, so this isn't part of the video of what I had before or even part of the notes. But just wanted to go through and show you what it's doing. Okay, so the antiderivative of this. So if I have 0, right? So the antiderivative would be capital F of x is going to be
Undefined.
Negative 1 c. Right? There'd be negative 1 x and then they'd divide by x. No, wait. It's probably just 0. Probably
It'd be 1 over c. No.
You guys got the plus c, right? And go with it. What do you say?
1 over x. No?
1 over x?
1 over 0.
It's not 1 over x. You're thinking though. You have to add an exponent, right?
Oh, no.
Oh.
Oh, so that's just x.
Right? X plus c. 0 is some number, right? Okay. So if it was going to look like this, let's look. 6, okay? Then it would be 6x, right? Plus c, right?
Yeah.
Yeah, right? Does that make sense? I added 1 to the exponent and then plus c. Now, what's the coefficient in front of that x?
1.
Not 1.
Oh, wow. Alright.
So if you remember this little rule here, that I'm always adding an exponent. So this number, whatever that number is, right, gets a variable. So, right, I'm adding an exponent, so that's going to give me my x, right, and then plus c. But just because this is going to be 0 times x, which is 0, this is going to go away, so my answer is just going to be plus c, right? So, when you see any number by itself, you add a variable and then plus c. And in this case right here, when I did that, it's going to become this. Just like 6 is just some number, right? Say yes.
Yes.
6 is some number. So what did I do? I added variable plus c. But in this case right here, since I have 0, it's going to be 0x plus c. So I can also rewrite that as just plus c. All right, so now my wheel of derivatives. We have sine, cosine, negative sine, and negative cosine, right? So when I do the derivatives, which direction do I go? I go clockwise. So an antiderivative would go, or anti-clockwise. It's the same thing. Depends on what curriculum you use.
Really?
You actually say anti-clockwise?
Yeah, Cambridge curriculum, it was always anti-clockwise. I know, that's weirdos. All right, those Brits. Anyway, so if we're starting at negative sine, and I want to go counterclockwise, that's going to give me positive cosine. So that'd be a capital G of theta is
Do we add C to it?
plus C. It's always plus C because C could be 0. It could be 0, it could be nothing. But we have to account for it in our math that there could have been something there. And this next one, I like this next one. So, let's see if you guys paid attention when I said earlier. So what are we supposed to do?
No, you're supposed to add first.
Add first, right? So it's going to be x to the 3 halves, right? Because I'm adding 2 over 2, right? I'm adding one exponent, so that's 3 halves. And then divide by 3 halves. But what about fractions? I don't like dividing by fractions. What do I do? Multiply by the reciprocal. So you guys are going to get so used to this that you could jump straight to it, right? So instead of saying divided by 3 over 2, you're going to say multiply by 2/3. So you would say this is going to be 2x to the 3 over 2 over 3. So you guys are going to do this so often that you'll be like, all right, dang, I got this right here. So, because sometimes you're going to get some nasty fractions, and just clean it up right away. You already know what's going to happen. All right, are we good with this? Are we happy now?
Plus C. Yeah.
Plus C. Thank you. Man, see?
Oh, that's a lot.
And
Oh, look at that.
Lovely. You know, I'm cool.
and my 2 people that remembered my plus C's. And right there. So, this is basically all my stuff. All of it.
Oh, jeez.
Yeah. It's all the basic stuff. Okay, yes, I'll do this one. All right. What is the derivative of e to the x?
E to the x.
So therefore, the antiderivative would be?
E to the x.
Thank you. Okay, let's see if you paid attention on this one. So 6x squared. So what is my variable going to be? X to the third. So let's start with that. So it's x to the third, right? And it has to divide by, it's divided by 3, right? So 6 divided by 3? 2. And minus sine x. So I'm going to take the antiderivative of negative sine. So it's going to be positive cosine of x plus c. Now, if you notice, I have all 3 individually that I did. Okay, some of them I did earlier, right? But now, I only have 1 c, right? So I did all 3 of these individually. So it's some constant that I got from all of those together. It's like C1, C2, C3. But it's just, no matter what it is, it's something, even though I added 3 different C's together, it's still some C, right?
Yes.
It's going to be some constant, no matter what. Even though I got some here, 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 and here.
Because you don't know if they're the same C, so you can't
Yeah.
multiply them.
And so it's just some C. Does that make sense? E's good.
Will we ever find out what C is?
Yep. And it is solving. Nope. We'll start this tomorrow. That one's one right there.
Overtime, yeah.
Yes. All right. Don't forget, like, share, and subscribe. Hit that notification button.